So let's discuss on the pH indicators. This is one of the most interesting area which is really used to identify the concentration of the solution. Here is the index. I am going to talk about the pH indicators. The titration of strong acid against strong base. Example is HCl versus sodium hydroxide. Titration of weak acid against strong base. The typical example is oxalic acid versus sodium hydroxide. The titration of strong acid versus weak base. Example is HCl versus sodium carbonate. Titration of weak acid against weak base. The acetic acid versus ammonium hydroxide. And afterwards I am going to talk about OSTWALD'S theory and quinonoid theory. Here typical 3D of how the titration of strong acid against a strong base is. HCl versus sodium hydroxide. And this is a typical structure and 3D of how the titration of weak acid against a strong base. So oxalic acid versus sodium hydroxide. And this is on the titration of strong acid versus weak base. The typical example is HCl versus sodium carbonate. So OSTWALD'S theory is one of the major theory which will tell you like how the pH indicators are working with the acids and bases to make some ions. Let's move on. An indicator is a substance which indicates the completion of a reaction by sharp color changes at the end point without taking part in the reaction. So phenolphthalein indicator is pink in an alkaline solution. Methyl orange indicator is red in an acid solution. The substances which are used to indicate the end point in acid-base reactions are called as acid-base indicators. The typical examples of phenolphthalein and methyl orange. Those substances which change to specific colors in different pH range values of the medium are called as pH indicators. Incidentally, pH indicators are used as acid-base indicators also. Every pH indicator changes its color specifically in a ranging pH which is called as indicator range. For some of the indicators, the indicator range are given as below. Methyl orange, the pH range is this one. In acidic solution it's pink, basic is yellow. Methyl red, the pH range is this one. Acidic solution red and the basic solution is this one. And phenol red and phenolphthalein is this one. When a base is added to a solution of an acid, the H plus ions will be slowly neutralized by the OH minus ion of the base. Hence, there is a steady decrease in the H plus ions concentration and pH value increases uniformly. At the end point, there is a steep rise in the pH value. The pH values can be plotted against the volume of the base added and the curve so obtained is called titration curve. The titration curves are useful in the choice of a suitable indicator in an acid-base titration. A suitable indicator in an acid-base titration is one whose range is well within the sharp rising portion of the titration curve. Thus, the choice of a suitable indicator for any titration depends on the nature of the acid and base involved and the working range of the indicator.